So today we're going to talk about linear regression. This is a review from algebra. Sometimes we call it line of best fit. So let's define what a linear regression model is, also known as a line of best fit. This is a linear, now don't forget linear means a straight line, equation in the form y is equal to mx plus b. Now that's slope-intercept form. And it models the behavior of the data. Now, one cool thing about our regression model, or line of best fit, is that we use it to predict values. So we use the fact that it's a function, and we can plug in some numbers and get out some things that will help us kind of predict what's going on for another situation. Okay, so everything for this is on the calculator. So I've got all of the calculator directions listed out for you in case you forgot. Now, you need your calculators out. You might have to pause the video and write these down. So the first thing you want to do is turn your diagnostics on. This might be something that you haven't done in algebra. So you press second 0 and it takes you to the catalog. Now, if you look above the buttons, they've got little letters. I'm sure most of you guys have typed little messages up here. But once you get into the catalog, if you press the X to the -1 button, there's a D above it. So press that, and you're going to scroll down to Diagnostics On. Press Enter to get the Diagnostics on your screen, and press Enter, and it'll say Done. The next thing you got to do is you have to put in your data. So most of the time you're presented with coordinates. You have X value and a Y value. One thing depends on the other. So you press the Stat button, and then you're already on the Edit menu, so it says under the Edit menu, and you're already highlighted on number 1 Edit. So just press Enter. And then you have two lists. You have L1 and you have L2. So for L1, you're going to put the X values, and for L2, you're going to put the corresponding Y values. Now, you need to make sure you put in your data correctly, because if you don't put your data in correctly, you will not get the correct linear model. So, a big thing here is a lot of people delete the lists whenever they try to clear them. So, to clear out previous data, what you do is you scroll up until L1 or L2 is highlighted. You press clear, and then you press arrow down. Do not press the delete button. If you press the delete button, it'll delete the entire list. Now, I'm not sure if you've had to look at the actual scatter plot for this data before, but we're going to be looking at the scatter plots. Now, we're doing all kinds of regression in this unit, so we're going to get used to looking at the scatter plots with our linear models. So, you press second y equals, and that takes you to stat plot. Above y equals, it says stat plot. Now, you're going to select number 1, and it says plot 1 ... and it either says on or off. So press Enter for that. Then make sure on is highlighted. Alright, and then when you get done with that, we've got to set our window. Now, this seems tricky, but it's really not. So you go through your list of your X values and your list of your Y values. Go through the list of the X values. So for the X min, for this one, you're going to set that value to something that is smaller than your smallest X. So if your smallest X is 2, you could set it to 1. For the X max, you're going to set it to something that is bigger than the biggest X. So go through your X list, find the biggest X value, and then make it bigger. So if your biggest X was 80, you could make it 82. Now, the Y's are similar. The y min, you set something smaller than your smallest y, and your y max, you set something bigger than your biggest y. Then to look at your scatter plot, you press graph. So that window just shows all of your data, and you have your scatter plot. The next thing you're going to do is actually create your regression model. So you press Stat, you go over to Calc, and you're going to go to number 4, Lin Reg, AX plus B. Now this AX plus B is the same thing as MX plus B, except for they're using A instead of M to represent the slope of the line. So press Enter until your model appears. Some of you guys are using different calculators and you have to press Enter different times. So just press Enter until you have something similar to what I have over here. So this is my little fake screen over here because I don't have the calculator to pull out in front of you. So at the top will be y is equal to ax plus b. Then you have all of this stuff. Now your a and your b, this is what we use to write the model. So all you do is you plug in the a and the b for the model. Now your r squared is your percent of explained variation, and we're going to talk more about that in a minute. And then your r is your correlation coefficient, which we're also going to talk about in more detail in a minute. Now, if you do not have your diagnostics on, these do not show up. So if you're not having these show up, make sure your diagnostics on. And when you're doing these, if you turn your diagnostics on at the beginning of a problem set, you don't have to do it for every single problem. Just make sure it's on when you initially begin to work on some of these. Now I'm going to explain to you a little bit what the r squared and the r are. Now your r squared is your percent of explained variation. It measures how closely the line fits of the data. So this is a percentage. So suppose that your percent is 85%. So what this is saying is that 85% of the data is explained by the regression model that we have. So the higher the percentage, the better, because we want it to make the most accurate model as possible. Now the r is your correlation coefficient. It is a value that is between -1 and 1 that tells you how closely related, and in this case linearly, the data is. So this tells you how close in a straight line your data is. And we're going to talk about r in just a second in more detail. Okay, so more on the correlation coefficient. We can think of it as a number that is between -1 and +1. So it's somewhere on this scale. Now, the closer it is to -1, so something like -0.83 or -0.9, what your data looks like is it looks like it's almost in a straight line with a negative slope. Now, on the flip side, the closer it is to +1, so something like 0.83 or 0.97, what you have is a strong positive correlation. So that means the same thing as strong negative, except for we have a positive slope here. So strong negative, we have a negative slope, and strong positive, we have a positive slope. Now the closer it is to 0, we'll have no correlation, meaning our data has nothing to do with each other. This could be something like plotting somebody's shoe size for the x values and how many cats they have for the y values. Because think about it, shoe size and cats have absolutely nothing to do with each other. So it would probably have a correlation coefficient really close to 0. Okay, so I need for you to get that worksheet. On one side it says line of best fit, and the other side it says real world something another. So we're going to look at the side that says line of best fit first. We're going to do a few of these together. So, number 1 says, a student who waits on tables at a restaurant recorded the cost of meals and the tip left by single diners. So this is definitely something that would have something to do with itself. So in our little table we have meal costs and then we have the tip that goes with it. So these are my x values and this is my y values. So it says we need to write the line of best fit or the linear regression model, and then we're going to answer the question that they're asking us. So you need to make sure diagnostics on, so press second catalog, your x to the -1 button, and go to Diagnostics On and press Enter until it says Done. Then you need to put in the data. So go Stat, Edit, and we're going to put in the data. Now, once you get the data in, make sure that your lists match up. Make sure you put the corresponding X and the Y values together and you don't get them mixed up. Now we've got to find, well, we're going to take a look at our scatter plot. So make sure your scatter plot is on. And once you turn your scatter plot on, you don't have to turn it on anymore. So then we're going to set the window. So press Window. Now remember, the X-min is you find the smallest X and you make something smaller than it. So the smallest X value we have is 4.75. So something that would be smaller than that would be 4. So let's just make that a nice even round number. Now the X max, our biggest X value is 20.42. So our X max, we need to make something bigger than 20.42. So let's just say 21. So there's also X scale in there and Y scale, but we don't have to worry about that. So now let's go to Y min. The smallest Y value is 0.50, so let's just make that 0. And the biggest Y value is $3, so let's just go up 1 and we'll do $4. So press Graph and you'll have your scatter plot. So let's take a look at our scatter plot. Now let's kind of predict what's going to happen with our R value. Now we're definitely going to have a positive correlation coefficient because we look like we have a positive slope. And that makes sense. The more money you spend at a meal, the more tip you're going to need to leave. Because the standard for that, most people will say, is 15%. So now let's do our line of best fit. So we press Stat, over to Calc, and we go to 4, Lin Reg, and press Enter. Sometimes you got to press it a couple of times. And we have what pops up is a bunch of, we got long decimals here. So let's just do 4 decimal places. So we have Y is equal to, and we're going to put the A there. So we have 0.1569. Then we have our X plus, and then our B is negative 0.2992. So there's our equation. That's our line of best fit. That's our linear regression model. So now we can answer the question. The question asks, if the next diner orders a meal costing $10.50, how much tip should the waiter expect to receive? So they're giving us an X value, and we're looking for how much tip. So we're looking for a Y. So what we're going to do is we're going to take our equation here, and we're going to plug in 1050 for X. So we have 0.1569 times 1050 plus a negative 0.2992. So let's put that in the calculator and see what we come up with. Okay, when you plug that in, you get, and we're going to round to 2 decimal places because we're talking money here. So $1.35. So that should be how much the waiter would expect to receive in a tip if their diner spent $10.50. Okay, so let's take a look at number 4. We're going to skip 2 and 3. You're going to do those later. So it says the table below gives the height and shoe sizes of 6 randomly selected men. Now, think about it. These might have something to do with each other. We're about to see. So X is the height and Y is the shoe size. So we need to create our line of best fit, and we're going to look at our scatter plot. So we already turned our stat plot on. We've already turned on our diagnostics, so we're going to skip those steps. So press Stat, Edit, and don't forget to clear out these lists. You go up and you highlight L1 and L2 and you press Clear and arrow down. Do not press Delete. So let's put in this data. Once you have your data in, let's go take a look at what our scatter plot looks like. So let's go to Window. So our X-min, the smallest X value we have is 66. So something that's smaller than 66, we could say 60, I don't know, let's just say 64. Now the biggest x value we have is 78. So something bigger than 78, let's just say 80 for our x max. So let's do our y min and our y max. The smallest y value we have is 8. So let's just do one lower than that. So let's set our y min to 7. And our y max, the biggest y, is 13. So let's do something bigger than 13. Let's make that 14. Press graph and take a look at it. So this one looks pretty straight. So now let's make our line of best fit. So stat, over to calc, and we go to number 4. Press enter until it pops up. Okay, and let's write our equation. We're going to do 4 decimal places. We have y is equal to 0.4211 x plus negative 19.8127. So there's our linear regression model, our line of best fit. So now let's answer the question that goes with it. It says if a man's shoe size is 10.5. Now that is a y value this time. What would his predicted height be? So we're looking for an x. So that's why we're doing this one. We're given a y, but we're looking for an x. So what we do here is in this equation, we're going to plug 10.5 in for y. So we have 10.5 is equal to 0.4211x plus negative 19.8127. Now we're going to solve this just like a regular equation. We're going to add 19.8127 to both sides. And we get 30.3127, and that's still equal to 0.4211x. Then we divide by 0.4211 on both sides. And then for that we get 71.9846. So 71.9846 is equal to x. So the height you can expect for that person be 71.9846. And what's the unit on it? We have, well, it didn't give a unit, so that's just the height. Okay, so now let's flip over to the other side. For the directions on this one, it says for each set of information, answer A through C. It says what is the line of best fit? So what is the linear regression model? What is the correlation coefficient? And interpret its value. So we're going to look at the R. And it says find the missing piece of information from the table. So let's look at number 1. Now the missing piece of information they're talking about is this. So when we're doing our line of best fit, we're going to leave this off. So this is like what we did in the other ones. We have an X, we're going to plug in a Y. Plug in the X to get out the Y, excuse me. So all it's asking for is the line of best fit. So let's go ahead and put in our data. So stat, edit, and let's put in our data. Make sure when you clear out your list, you just highlight and press clear. Do not press delete. Also, when you're putting in the data, make sure you do not put in that 8. So A says find our line of best fit. So go on your calculator, press stat, over to calc, and go to 4, len reg. Press enter until your line pops up. We're going to do 4 decimal places again. So we have y is equal to negative 73.0700, 4 decimal places, x, then plus 650.2693. Okay. Then B says we want to interpret the correlation coefficient. The correlation coefficient is your R value. So your R value is negative 0.91399, so 9140. So the way we interpret this is if we go back to that scale, so I'm going to flip back to that scale. We have something that's close down here at this end. We have negative 0.9 something. So we can easily say that we have a strong negative correlation. Okay. And the last thing it says is find the missing piece of information from the table. So like I said, we didn't put in that 8. That's our x value. So we're going to use our line of best fit, this guy right here, and we're going to plug in 8 for our x value, and we're going to see what we get out for y. So negative 73.0070 times 8 plus 650.2693. So let's put that in your calculator. Actually, I goofed up writing right here. Oop. Got my zeros and my sevens mixed up. That should be 0.0700. So when you put that in the calculator, you get 65.7093. So that's approximately how much money you would spend on repairs if you had 8 oil changes per year. So this is money, so I'm going to put a $sign. So that's our answer for C.